In this example, we're going to look at writing a fraction as partial fractions, but where one of the terms in the denominator is actually a quadratic term. So in this example, the quadratic term in the denominator is x squared plus 3. So that makes the form of the partial fraction slightly different to a partial fraction with linear terms in the denominator. So let's see this. So this is our original expression, and that's going to be equivalent to a over x minus 2, and then we're going to have our term over x squared plus 3. Now, because we've got a quadratic term in the denominator, we actually need a linear term in the numerator, sort of 1 power lower than what we had in the denominator. So on top, we're actually going to have, we're not just going to have b, but we're going to have bx plus c. So this is the form that this partial fraction is going to take, and we need to work out what a, b, and c are. Now, standard method for partial fractions, we're going to multiply both sides by the denominator. So multiply both sides by x minus 2, x squared plus 3. The left-hand side becomes 3x plus 1, and the right-hand side becomes what we get a. The x minus 2 cancel out, and we get ax squared plus 3, and then we get bx plus c, and when we multiply this bx plus c over x squared plus 3 by x minus 2 x squared plus 3, the x squared minus plus 3 cancels out, and we just get an x minus 2 term left over. Okay, great. So now we can substitute values of x in order to find out what a, b, and c are. So first of all, the easiest way to start is to substitute x equals 2, because the x minus 2 bracket will disappear if we substitute x equals 2. So x equals 2, the left-hand side becomes 6 plus 1, and that's equal to a times 2 squared plus 3 plus, and as I said, because x is 2, this x minus 2 bracket cancels out, so we get a 0. We get 7 equals 7a, so a equals 1. Okay, good start. Now, our next thing to choose for x, well, probably the best thing to choose next is x equals 0, because the bx term will disappear when x equals 0. Let's try x equals 0. The left-hand side gives a, 0 plus 3, so a times 3 equals, sorry, I missed the left-hand side. The left-hand side gives 3 lots of 0 plus 1, so the left-hand side gives 1, and that's equivalent to a times 3, as I just said, plus, now the bx is nothing, we just get c times 0 minus 2, so it's minus 2c. So 1 equals 3a minus 2c, but we know a is 1, so this is equal to 3 minus 2c. So solving that, minus 2 equals minus 2c, c equals 1 also. Great, so we've worked out a equals 1, c equals 1, just written those at the top, and now we need to try to find b. So I'll free some space up. And again, the same idea. To find b, we're just going to substitute a value of x that we haven't tried before. Choose a simple value of x, so let's try x equals 1. So if x is 1, the left-hand side becomes 3 plus 4, and we get a, 1 squared plus 3 plus b times 1, so it's just b plus c times 1 minus 2. So 4 equals 4a, 1 squared plus 3 is 4, plus, so we get 1 minus 2 is minus 1, so we get minus b minus c. And we know a is 1 and c is 1, so we get 4 equals 4 minus b minus c minus 1. The 4's cancelled out, we get 0, well, we get b equals minus 1. So again, I'll just write this at the top, a equals 1, b equals minus 1, c equals 1. So then going back to our original expression that we laid out, we can just substitute these values. So our final answer is going to be, this thing is equivalent to 1 over x minus 2 plus bx plus c, so that's minus x plus 1, so it's 1 minus x is bx plus c over x squared plus 3. And that's it. That's our final answer.